And starting the questioning this time, Professor Teddy Hall.
Peter, you've used the magnetometer for doing geology. Do you reckon there are other uses which you might put it to?
Well, certainly magnetometers as a whole are instruments that can measure magnetic field strength, and as such their applications would reach to any form where one is required to measure magnetic field strength. This could range from specialists like for an archaeologist who would look for kilns and buried walls and things, or to take a more recent example, for instance, up in Scotland, where several people were trapped in cars beneath snow. The car, being comprising of a fair amount of metal, would be detectable from a magnetometer, say, flown from a helicopter. And as such, instead of wasting time prodding the roads, they could have sent parties straight out to the cars. And
they could even have gone on foot and used the magnetometer, presumably.
Yes, they could have done, yeah.
Richard, you used a number of other methods as well, didn't you? Which was the best for a geological survey of this kind?
Well, the other two methods we used were the seismic method and the resistivity method. They both have their values. The seismic method, A, tells us the depth of the rock we're working above.
Which the magnetometer doesn't do.
Which the magnetometer doesn't. And it also tells us the speed of sound in that rock. But the resistivity does tend to give us a little more value as regards complying with a magnetometer survey.
So which is the best?
Probably the resistivity.
Better than the magnetometer, you think?
Oh, no, no.
No, you mean
Out of
of
the
those,
two.
the magnetometer was the
The
most
magnetometer
useful.
is the best.
I see.
Yes.
John, on this project you collect a very large amount of data. What do you do with it? How do you handle it?
Well, we take it, I wrote a computer program, and after we've got the data, we then take it to the computer, which turns it from readings of time to a measurement of magnetic field strength. Before I'd written this, we used to have a set of tables to use. And they were very fiddly things. And
very laborious altogether.
Yeah.
John, what sort of magnetic differences are we talking about? How much do they vary over the whole field?
Most we've had is some 3%. The smallest is 2 parts in 50,000.
And what's that's about the limit? What can you measure?
Well, we managed 3%.
You measure
we could manage much more than that, without retuning the without sort of doing part of it.
Yes, I don't mean on that side. I mean, what's the precision? What's the smallest difference you can measure?
The smallest, really about 1 part in 50,000.
1 in 50,000.
Well, that's the precision of the instruments, to say 2 to be sure.
2 in 50,000 to be careful, though. Right.
Richard, you've obtained occasional odd results, particularly in wet conditions. Can you tell me how this comes about?
Well, we were doing a seismic survey on a very wet day once, and the ground was wet and very soggy underfoot. And to do the seismic survey, we have a metal anvil, which we hit with a sledgehammer. And when the sledgehammer hits the metal anvil, the inertia contacts close, which is what starts the clock. Mm-hmm. But the idea of this is to put the sound energy into the ground and measure the speed of sound in the ground. But because the ground, I think, was very wet, the first signal to get to the geophone, and after all the geophone is stopped by the first signal which arrives there, was the signal through the sound through the air. So we got a straight line graph which worked out the velocity to be 308 meters per second, which is the velocity of sound in air, approximately.
And you got fairly quickly onto this, did you? You realised what was happening fairly quickly?
Yes, yes.
John, I think you've drawn a map of your findings with the magnetometer and the other techniques. How does this compare with the other two geologists who also made maps?
Well, in general, it doesn't compare with theirs much. We both agree that there is a fault between the Malvern Hills, which would be here, and us, and the intrusions which are that way. But we have put these in a rather different direction to them. We've got a different number. We've added this extra bit of, and we've added these 2 extra bits of fault here. Yes. And this is, at the moment, is our present map.
I see there are 2 colours there.
Yes.
There's the yellow and the green. What?
Yeah, well, the green ones are the ones we're fairly certain are there. And the yellow ones are the ones which we think are there, but no, they need confirming.
And the other map?
The other map is the one we had during the heat. This bit here has been altered because there was a mistake in it before, but we've done some more work in this area, which is the same as this bit, and that is really what's made our minds put this extra fault in.
And these differ quite a lot from the earlier workers, don't they, John?
Yes.
Who's right?
We think we are, naturally.
And some more absolutely excellent answers there, this time by the team from Malvern College. Pollution next, and in particular air pollution. The boys from Kenton School in Newcastle have been looking at how much there is of it in their particular part of the world. Of course, the Clean Air Act has done quite a lot to get rid of it, but that doesn't mean that it's completely disappeared.
We decided to investigate sulfur dioxide pollution in the Tyne and Wear area. To start with, we investigated methods of measuring sulfur dioxide levels in the air.
On the school roof, the team set up a monitoring station. Polluted air is sucked through a solution where the sulfur dioxide is absorbed. By measuring day-to-day changes in the amount of sulfur dioxide collected, they're trying to understand how the weather can influence levels of pollution.
One of the main correlations which we found was between sulfur dioxide levels and relative humidity. As you can see from this graph, the sulfur dioxide and relative humidity follow the same general trends up and down, although there are, of course, places where they do not agree.
Daily weather information came from the log at Newcastle Weather Centre. The team had to extract the particular information they needed from the mass of data contained in the log. These and thousands of figures relating to sulfur dioxide levels were assembled and fed into a computer.
With all the extra data which we will now collect and the more powerful computing facilities which we will have, we hope to be able to work out the effects of weather variables on sulfur dioxide and even to predict sulfur dioxide levels in the future.
Time for questions to Kenton School, and Sir George Porter, as a chemist, is the obvious person to lead them. George.
So let's start on the chemistry, John. What's the best method, do you think, you've used a lot for measuring sulfur dioxide concentrations?
Well, the most accurate method which we used, in that it only measured sulfur dioxide and didn't take into account things like nitrogen oxides and hydrogen fluorides, was the Westgeek colorimetric method. That's a standard method which is used in the United States a lot. The method that we found the most convenient and quick to use, because that colorimetric method is rather fiddly, the one that we found the quickest and easiest was one similar to that, a conductometric method which measured the change in conductivity in a hydrogen peroxide solution.
Mm-hmm. Ian, you're a chemist, aren't you? Which, you agree with that? Are those the best? Now, what do the environmental health people in Newcastle use, the professionals?
The equipment, the type of equipment they use is that type there. It uses hydrogen peroxide again, only this time it's a change in pH.
Measuring the pH?
Yeah.
And
but the trouble with this method is that it also measures other gases in the air.
I see. So you don't really agree that the method they use is the best one?
Yeah.
You better tell them so.
Jonathan, as very much a non-chemist, can I ask you about your work on lichens?
Yes, well, Gilbert invented a scale in 1968, and this scale relies on the fact that sulfur dioxide dissolves in water to form sulfurous acid, which poisons lichens, and different lichens are poisoned at different rates by this. So consequently, in areas of high sulfur dioxide pollution, you find very few lichens, and in areas of low sulfur dioxide you find a wide variety, many sort of exotic types of lichens.
It's what we call a good qualitative method.
Yes, it's a qualitative scale, but you can't actually give any readings from it. You can't say, give a value for sulfur dioxide in an area from the lichens there.
Michael, you've done a lot of computer work and worked out correlations from your computer. Do you think now you can rely on these correlations to tell you what, in fact, the sulfur dioxide is going to be in a particular area, the pollution?
Well, the computer has given us some good correlations with the sulfur dioxide between the average temperature, the wind speed and the rainfall. And we've tried to make up a regression analysis which will predict sulfur dioxide given a set of weather variables. However, we feel that at the moment there's one variable missing because the equations have an inaccuracy of 30–40%, which we feel is too high.
And you're looking for this, or
Yes.
this other
We think
possibility?
it's possibly connected with dispersion in areas of production, but we've still got to do some more work on that.
But if, John, you get a correlation between, say, humidity and sulfur dioxide, does this mean the humidity is causing the increase in sulfur dioxide?
Not necessarily. There's a distinction that we grasped when we started the second set of our analysis. Because sulfur dioxide varies with relative humidity, it doesn't say that it varies because the relative humidity varies. In fact, sulfur dioxide varies with average temperature, and because relative humidity by definition depends on average temperature, then sulfur dioxide varies with relative humidity. In fact, if the relative humidity goes up, it probably doesn't affect the SO2 level very much.
If the humidity stays the same, yes.
That's right.
Ian, supposing you could predict now, as a result of your work, what's going to happen to SO2 the day after tomorrow, if you know the weather, what use would this be? What could you do about it?
Well, it would be very helpful for people with bronchial diseases, because we've found about some research in London which shows that people with bronchial diseases are affected greatly by the amount of sulfur dioxide in the air.
Yes.
So if they were to stay in the house or wear, say, a special mask to cut out sulfur dioxide, it would be very good for them.
I see, rather like pollen count
Yeah,
things. Yes, thank you.
And those were the winners from heat number 3, the team from Kenton School in Newcastle.